Hello, welcome back. So in today's lecture, we're going to be looking at leveling, terms, and definition. Alright? Leveling, terms, and definition. Okay, so let's quickly check up what these leveling terms are before we come back to this particular window here. And to check the notes, leveling terms. Okay, sorry about that. Leveling terms and definition here. Okay, now we have the first term, benchmark, the second term, datum, backside, foresight, intermediate site, change point, reduced level. Okay, reduced level. So we're going to be looking at all these points here. We're going to be looking at everything here, right? And just before we get into looking at this, each of these points, each of these highlights you're seeing here, let's go quickly into a systematic diagram of the Earth when it concerns leveling and setting up reference points. So you can understand from that picture, and then we can set up a simple diagram so to understand every other thing here. So I'm going to take you back there to that window. Now this is the diagram of the Earth. This is actually the diagram of the Earth here, this place. Okay, now imagine the Earth is cut into four sectors such that it is kind of 90 degrees to the horizontal, like four equal sectors. Now let's take a part of one of these sectors and see what it represents. You can see that in one of these sectors, what is actually here is the top part of the Earth, which includes the mountains and the ground where we walk actually, and the sea. You can see the seabed and sea level somewhere, the sea level, the seabed, and some other parts of the seabed. All right, so what I want you guys to understand is actually what we call the reference body, reference point, whatever you call it. Okay, all I want you to understand is point of reference. Okay, now let me take this out. The diagram of the Earth is just what you're looking at. Okay, every point on the Earth has elevations. All right, this is a systematic one you're looking at. Okay, now before surveying, or during when surveying was older, or in the older days of surveying, okay, surveyors usually use the seabed to measure anything as a point of reference. Okay, in physics, before you find the position of B, you must have already known the position of A, meaning that the position of B is dependent on the position of A. All right, so A is a reference point of B. If I'm saying, if I want to determine the distance B is farther from A, then I'll say B is 30 meters from A. All right, now that makes a lot of sense because you already know a point A. The point A serves as reference point actually. Okay, now again, imagine I said the point B is 30 meters. It doesn't make any sense because a point can't just be 30 meters. 30 meters from where? And that's where we are getting to. Okay, now I'm just talking about a linear distance. That's just what I'm talking about. Okay, now in this particular case, instead of me to talk about a kind of a horizontal distance, this time I'll be talking about a vertical distance. Okay, Now you can see that in the diagram you're looking at something made up more like a ruler pinned on the Earth's surface such that it's inclined at 45 degrees from this place over here. Then you can see that on the sea level, actually, on the sea level here, this place, I don't know if you're actually seeing this highlight here. Now on the sea level, it is 0. Okay? Now it means that everything that is built on this region up has elevation from this 0. Okay? Which means from the sea level. Okay? Now also everything that it's found under has a depression or a depth. Actually, you can see this. This is a depth or a depression. Then from this 0 up is your elevation. Then from this 0 down is more like your depression or your depth. Okay? Now this circumference or arc you're seeing here is just called the sea level, and it is considered as the 0 point. Now you may be asking a question that the sea level is not actually straight. Okay, fine. Surveyors do determine which part of the sea is actually balanced or is actually not disturbing, okay, with a device, a gauge device. Okay, so they sink this gauge device inside of the sea, maybe weeks, maybe months, or sometimes yearly. Okay, so by the time they come back to check it, and they do what they have to do, and they now determine a point from the device. They now determine the point where the sea is just balanced, it's not disturbed. Okay, so that is how they do it. Now that's not my rule here. My rule is to make you understand that every position on earth is built with respect to the sea level. Every height or elevation on earth, I repeat, is built or calculated with respect to this sea level here. And so therefore you can see that the ground level here, all these places you're seeing here, all these brown places you're seeing here, including the mountains, are the earth's surface. And from the topper part of them to, if you trace it deep down, you can see that it is between the normal ground level we work on is between 0 to 2 kilometers or 0 to 2,000 meters actually. All right, so you need to understand that. Now you can see that this particular area is Mount Everest. Mount Everest has a height of about 9,000 meters. Okay, of about 9,000 meters. That is somewhere here. It's called the elevation. From where? From the sea level. Okay, now likewise, this is the elevation of the land surface from 0 to 1 kilometer actually, but I'm just approximating to 2 kilometers. This is actually from 0 to 1 kilometer, and that is some place in the on Earth's surface can be 500 meter height or elevation from the sea level. You know, it's not just 1 kilometer. It can differ 200, 300, like that, and the likes of the rest. And okay, now you can see this other place. Now this particular hip here on the inside the seabed, you can actually see that it is called the Mariana, and it's just about 0 to maybe 500 meters. You get something like that. It's just about 0 to 500 meters elevation. Okay, now the deepest part of the seabed is called the Challenger. The Challenger Deep. This is it actually here, and it's just about 11,000 meter deep. You can see that from this sea level, from this particular sea level down 11,000 meters deep. Again, the bed of this particular ocean is just about from maybe 4 to 5 kilometers. All right, you can just see that some places are 4. You can see from here. Some places maybe 5. Some places are even 6. All right, it's just an approximation. All right, so you can see that this actually answers some part of the question of where is our reference point. Our reference point is this sea level, a steady part of this sea level. Okay, so that's what we need to understand. Now, I want to explain something. You know that when surveyors who carry out earth work, the sea is not always present to use it as a reference point. Okay, as a result, surveyors do what we call transfer of a known point. Since they already know the sea level is our reference, is our starting point, they now start transferring elevation, known elevation, to the point to any point on the ground surfaces. Now, this known elevation is known as benchmark. This is made so that the known heights or the known elevation as sea level as a reference point could be available everywhere on Earth's surface. Okay, now it's very easy to find because there are systems, a lot of computer systems or a GPS, where you can use it to locate a benchmark with elevation. Okay, but then these benchmarks is more like building a concrete into the ground. A concrete is more like a stone, designed stone built into the ground, which height or depth from the sea level actually gives a known reduced level. All right, so the sea level is now known as a reference point. So you get that. I've just defined your benchmark here. I just defined your benchmark. I said benchmarks are points on Earth's surface which has a known reduced level or a known height actually. Okay, they help in the actual process of leveling. Okay, now the sea level is also known as datum. What is datum? A datum is a reference point in which other points are known from it. Okay, so the sea level is called mean sea level, is used as a reference point. Okay, in which other points on Earth's surface, such as this mountain here, such as this ground level here, are known just from it. Okay, the sea level here is also known as datum. Okay, so you need to know that one too. So for us to break things even deeper, let's go to what we call a simpler diagram that will explain the entire system you're looking at here, as well as the other ones you have looked at before. Okay, so let's say this is where we were. Okay, we have defined datum, we have also defined benchmark. Okay, now let's get to another diagram. Now what you're looking at is a diagram which has points on the Earth's surface. Now these points can be mountains, these points can just be normal manhole, these points can just be anything at all on the Earth's surface. But instead, I label them 0.2, 1, 0.1, 2, 3, 4, 5, and 6. Alright. Now, I am to know the elevation of all these points here. Okay. Now, if you check under, if I'm to zoom enough, If you check under here, you're going to see that you would see something called the mean sea level. Okay, so I drew this actually downward, and so that it will be very easy to visualize this on your in your minds. Okay, so note, these are just points on the Earth's surface. Imagine these things are normal things we see in real life. Okay, but it's just a systematic diagram, a simple diagram in which it will help you to understand it. Okay, so zooming it closer a bit. Now, these are my two instruments. We call this one leveling staff, and then we call this other one the instrument itself, the leveling instrument or the telescope itself. Okay, now to determine the level of point 2, I must already know the level of point 1. Okay, now because I want to already know, because I'm assuming I've already known the level of point 1, the reduced level of point 1, then I will assume that point 1 is a benchmark. Okay, to determine the position of point 2, I must already have found another point which I know that it is a benchmark, and I also know its elevation or reduced level. Okay, now it's very simple. Assuming the point 1 is that point which I know it is a benchmark, okay, and which has a reduced level, remember, which has a reduced level, this line here is tracing point 1 down to the sea level, so which has a reduced level of let's say about 200 meters. Okay, and this reduced level is known as what we call benchmark. If we check, okay, now that is just what you need to know. Let's say the distance from this point down to the sea level is 200 meters, and then it is called benchmark, the reduced level of benchmark actually. So RL of benchmark, it's about 200 meters deep, not sorry 200 meters high from the sea level, you get. So it has a reduced level of 200 meters from this sea level here, from this mean sea level. Now going further, what do I want to know? What do I want to know here? I want to know the reduced level of this point here, of point 2. That means I want to know the height of point 2 to the sea level. That's the reduced level here. Okay, now I don't know, I've already seen a point on Earth's surface which I call the reduced level, and I already know the point, the height already, the reduced level already, to be what? To be 200 meters. Okay, we call it the benchmark because why? It is known. It is a point known on the Earth's surface which has a known reduced level of 200 meters. Okay, so to go further, we will use this staff and place it on this point 1, just on top of this concrete. Say this place is a concrete where it just indicates the reduced level. So this staff will actually be placed on that concrete. Now, this other instrument here will be placed somewhere around the ground level where I can view the staff. Okay, it's called the instrument. All right, the total height we'll assume later, we will find later, will be called the height of instrument, and I'm coming to that. Okay, now let's get this here. You pin it somewhere around the site. Let's just say it's somewhere around here. Okay, to assume to actually find the height. Now this is the height now. Meanwhile, this is from this point to this point is a reduced level. Okay, then that is from the sea level. It can say the height of this this point now from the sea level is a reduced level. Okay, now this one is actually the height of this point 1 now to where this instrument is just facing. All right, so you can see the height of this point 1 to where this instrument is just sighting. Okay, now this also is the height of point 1 to the sea level. The height of point 1 to sea level is this reduced level. Okay, please, I have just told you for you to view the sea level very well. Okay, so let's go. Somebody will actually place his or her eyes on this particular side angle. You get to sight through this whatever you call it, this telescope, and then this is what the person does. This is it. Okay, fine. Now this is what the person achieves. Say this place now has a height. Okay, from this line of sight, this line where you sight this object, this particular stuff here is called line of sight. This line here is called line of sight. So imagine from this point to the line of sight, it has a height. Okay, now because it is the first reading on the sight here, taken on a known point, all right, we call that back sight. Remember here, back sight. Okay, because it's the first reading taken from a known point, we call that reading backside. Say the backside reading was about 2 meters. Okay, so I'm going to say that the backside BS reading was about 2 meters. Okay, it makes sense to me. Remember, it makes sense to me. What is backside? The first reading taken on a known point or on on the benchmark with a known elevation. Okay, that is backside reading. Okay, now somebody on the other hand, actually the instrument is supposed to be positioned this way, because where you're viewing, where your eye is supposed to view from, actually has a smaller lens piece, a smaller piece of lens. Okay, then where you're viewing the object is this ruler now. When you're viewing the object, it actually has a larger lens piece. Okay, so the object is positioned this way. All right, it's just a flip around. Remember, these legs are pinned to the ground, it doesn't move. Okay, so you don't move it until when you want to change point. That's when you move, and there are some rules to follow before you change the points. Okay, now this ruler will actually be moved to this other place. Okay, this ruler here, this staff would be moved to this other point, and because it will be moved to this other point, I would call that point something, but let's move it first. So imagine this ruler is now moved. This ruler is moved to this other point. Remember, is this point I want to know? I want to know this point's reduced level here, RL. That's what I want to know. I want to know this point RL here at exactly this point. Okay, so now I will turn this instrument towards the other side of it. I will turn it. I've turned it. Okay, now what am I viewing? Somebody, if the person was standing on this other side before, the person will turn to this other side and view this ruler here. This ruler is no longer here, but is now here. Okay, so the person will now view from here, view the ruler from this other side. So say the line he views the ruler was just somewhere here. Okay, he views the ruler through here now. Okay, so the height of this ruler from point 2 to this place, let's call it 3 meters, and hence the point is known as the height. All right, the height here, this distance is known as the intermediate sight. Remember, after your benchmark, the next reading is your intermediate sight. Okay, after your first reading, the next subsequent reading is your intermediate sight. except in the case where you need to change this level instrument. Okay, that is where you need another name for this height here. Okay, but then let's say it's intermediate site, and let's call the intermediate site is about what? Let's call it 3 meters. 3 meters here. Now I want to know I want to still keep my instrument here and read point 3. Okay, I want to read point 3. All right. Remember, my aim is to find the reduced level of point 2, point 3, point 4. So I would get their readings first before doing mathematical operation to finding their reduced level. Okay, so this is it. This stuff will disappear from here to here. Now, provided that I can still keep my instrument here and view through this stuff at this point, unless when I cannot view this stuff at this point from where my instrument is, that's when I need to change my instrument. But for now, I'm only changing the stuff since I can see that, okay, it's possible to view actually from here without distance limit from here at this point 3. Okay, from here to this point, we can view any object on this point 3 from where the instrument is now. So I can say, okay, let me duplicate this. So this stuff just disappears from there to this place. Remember, there are no more staffs here and here. This place and this place, there is no staff again. Okay, so what I'm going to do now actually is to cite this particular staff, this staff here, from here. So anything it gives to me would be the reduced level. Remember, the level instrument is still on that particular axis. I have not changed it. So somebody stands here and cites through this place. So let's say the height from this point 3 to the line of sight is what? Let's just say is assuming, let's say it's let's call it intermediate sight reading, which is 2.5 meters. Okay, so we have done that. Okay, now we want to move this instrument, this what do we call it? We want to move this staff to point 4 so that we can determine its the next intermediate site. We can see that, okay, from here to here, so we can determine the next intermediate site. All right, so what we do is actually this, moving this guy here is now here on point 4. Okay, but if you check, the instrument cannot actually view this stuff, because if you follow the line of sight will hit somewhere around this hill. It means it cannot view this stuff. Okay, but the instrument doesn't also have a way you can tilt this thing upwards so that it could view this stuff. I don't think so. Maybe let's assume that distance limits might affect us. Okay, so in that case, we need to change this guy somewhere that we can view this particular guy. Okay, maybe somewhere here. Okay, that is what we need to do. All right, so this is what we do. Because we cannot view the next point with the instrument, and because of the next point, we are going to be changing this instrument here to somewhere where we can view this next point here. We will call this last point here our what? Our 4 sites. Okay, this last point will no more be intermediate site, but will be our 4 sites. Because why? Because we want to change the instrument. We will call this last point where we just measured as intermediate site, we'll call it 4 sites. Okay, so that is the reason why we are doing that. So we'll call this guy 4 sites FS. Okay, now we move this instrument here, somewhere here. Remember, pin it on the ground, move it somewhere here. Now, this guy holding this staff here, remember the staff has not been transferred here. It hasn't been transferred here yet, because we want to do what we call change of point. So this guy here doesn't move until I view the backside reading of this staff before he can now move to this point where I can view the staff well, right? So I will flip this guy. That means I will rotate this head to just point towards the staff to take the backside reading. Okay, so taking the backside reading, this is what it means. I'll take this backside reading here. Okay, so that's the backside reading there. I'm taking it. Now, say the backside reading from the ground level to this upside, to this line of sight is called, let's just call it 5 meters actually. Yeah, let's say it's 5 meters. No, let's just say it's 4.5 meters actually. Okay, not just 5 meters. Let's say it's 4.5 meters. No, now this is backside. BS, say is about 4.5 meters. Okay, so this is the backside reading from this ground level to this place is 4.5 meters. Okay, now I will now turn to read this other side for, let me just turn to read this other side. So I'm reading this other side now. Remember, the height has changed. The height of the sight has changed. So I'm reading this other side now. You can see what I'm reading there will be about 1.5 meters, or let's just call it 1 meter. The next reading will be intermediate. Remember, as I told you, intermediate sight about 1 meter. We are just assuming something. Okay, so now we've taken this reading here. We want to take this other reading, and it is very possible to view from there. So we will just duplicate this guy, yeah, move it to this point. Okay, so what do we have? Let's view this guy from here. View this guy from here. Remember, this person doesn't move this leveling instrument. It's only the staff the person moves, not the telescope. Since it is provided that the person can, the surveyor here sighting all these staffs, since it is provided that he can sight all the staff from this position where he is, so he doesn't move from there. It's only rotating around this telescope like that, around the tripod stand. So let's say from this point to this point, let's say the next intermediate sight, IS, is about 4 meters. Okay, bring it here. All right, so let's move to another site. Now this is the last part here. Okay, can this leveling instruments from here view the last part here? Of course it can. But usually, if the distance is disturbing, you can actually shift the leveling instrument from here to here. Because if you're checking the leveling instrument from here, the distance might be disturbing here. Okay, it's too far. But if it's possible, let's assume it is possible to view here, because this is just lesson. Okay, we assume it's possible to view here. Otherwise, we move the instrument from where it is here to somewhere around here. Okay, so let's assume it is possible to view from this place. So we can now take this stuff from where it is here to another point. Okay, which point? 0.6, 0.6, 0.6 here. Okay, so imagine if we view here, what happens? Let's bring it forward. We view this guy from here, what happens? Let's see what happens here. Damn, yeah. So this is what we do. You can see that view there to this point. Say this point now is our next intermediate site, right? Next IS. Okay, so that's the point IS there. And let's say the point IS we'll just carry about say the height here is just about 3.5 meters. Okay, so we can actually see what this guy is. Okay, so what did we do? Watch, let me show you something. Remember I said this guy can be our IS, right? But look at it. This 0.6 is actually the last point we are measuring on the site. Okay, according to this example. Because it is the last point we are measuring on the site, we are not going to call it IS. Although, remember I said after the back site, the next reading is your intermediate site. Next one, intermediate site. However, as long as you don't change this instrument, okay, that falls inside the rule. But since this guy is actually our last reading, before we remove this instrument and then we stop reading, we record what we have on a sheet, on a survey, on a leveling field book. Okay, since we have just stopped reading, that means we are removing every instrument from the site, isn't it? Good. So this was our last reading. Since it is our last reading, we are calling it the foresight. Okay, so don't misquote me. That is foresight. I'm actually following the lesson plan there. This is our foresight. If there was another point continuation, we could have come behind here and view the back side of this point here. You get? So because this is the last point, this is where we are going to stop for now. And you see that? It's actually very, very easy. Very easy. Easy peasy. Okay? Now, the lines that runs through this instrument is called line of sight. Okay? The horizontal line here is called line of sight. This line here you're seeing here is called line of sight. Okay? The vertical line from the line of sight to the mean sea level is called the height of the instrument. Okay? The vertical line or the vertical distance from the line of sight, let me just measure, write that out. Line of sight. Then let me go to that other side and write it out too. Line of sight. Okay. So the vertical line, I think I'm going to change this color so that it stays very different and unique. Okay. So let's say this is a vertical line here. Let me call it blue. Okay. So the vertical line from this guy from this line of sight to the surface of the sea level, right? Let's just say to the sea level, is called the height of instruments. You can see the HI. Okay. You can see the HI. The height of the instrument, HI in blue. Okay. Now, for me to find the reduced level of 2.2, okay, I need to determine the height of the total height of the instrument. And remember, I know the back sight reading to be what? 2 meters. That is from this point to the line of sight is 2 meters. Now, from this point to the sea level is 200 meters. What do you think the total height here will be? Remember, that is the reason why you needed to know the elevation of this guy. Because if you didn't know the elevation of this guy, how would you find the height of instrument in this case? The height of instrument, remember the instrument we use is this instrument here. Okay? This instrument here, this was what we used. Okay? The height of the instrument now is just from the line where you sighted it down to the sea level. Okay? Imagine you're chasing to the sea level. I'm just putting it as a normal diagram, a represent like what you need to have in your mind whenever you're thinking of this guy. Okay, so that is just what I'm putting to you. All right, I mean leveling is in surveying is easy. Okay, if you can read this guy, and also can read any, if you can, once you can read sight through this, set up this and read this guy here. All right, it's very easy. Now look at this. This line constitutes of the reduced level of the benchmark plus the backside. So what does that tell you? It tells you that to get the height of instrument, I need to add backside to the reduced level of benchmark. Or let's just say backside plus benchmark is equal to what? Height of instrument. So let's say backside plus benchmark is equal to height of instrument. Did you see that? That is 1. That is what? 1. Okay. Now you can see that this backside here is 2 meters, and the reduced level here is 200 meters. So this guy here is going to be what? It's just going to be will be equal to 202 meters. 202 meters. Did you see that? Fine. Now let's get to another one. You know the total height here to be what? 202 meters. Okay. So what will now be this guy, this small fraction here? Since you know from here to here as 202 meters, what will now be this larger fraction here? It's just subtracting intermediate side from the total height that you know, that is the height of the instrument, to get what? The reduced level here. So reduced level of 0.2. Remember, this is also reduced level, but since it's a known point already, it's called reduced level of benchmark. That is reduced level of 0.1. Now reduced level of 0.2 will now be height of instrument subtract minus intermediate side. So I will say reduced level of 2 will be equal to height of instrument minus intermediate side. Okay. So it now like 202 minus 3 would give me about 199. So the RL will be equal to 199 meters. You get the RL of this guy, 199 meters. So that when I add 199 to 3 meters, it gives me the total of this, you get, of this HI. So let's go further. Now this is another one. Okay. This is my 4 sides. I know the total height here to be what? 202 meters. My 4 sides here is 2.5 meters. So what do? I'll subtract 2.5 from 202 meters. Okay. So to get my reduced level of 0.3. So I'll just say to get my reduced level of 0.3. This is what I'm doing here. Okay. So 202 minus 2, actually 2.5 is 199.5. So RL is equal to 199.5 meters. Okay. Now also note that this guy, let me bring this guy here, bring this other guy here, so that you will know. Bring this other guy here. Okay. Note that this is a backside reading, and this is where we need to change this height of instrument. Okay. You can see from this height to this height, and from this height to this level is not the same. Okay. Actually, this height might be higher than this particular height here. So it's called change of height. Okay. We are going to be changing the height now. Okay. So changing the height now. The last reduced level was this guy. 199.5, right? You add it to the backside reading. The backside reading is 4.5. Add it to 199.5. That is about 204. Okay, so the new height of the instrument is now 204. Let me duplicate that. Maybe around that time, yeah. It's now about 204. New height of the instrument is now about 204. You can even see that from the line, you can see that it was actually shorter. Okay, so 204, the new height of the instrument is about 204. It was actually reduced level, the last reduced level plus the backside, which is now 204. 4 meters. Okay, now we see the same thing we did here. If you check, height of instrument is equal to backside or reduced level plus is equal to backside reading plus benchmark reading or reduced level of benchmark. Now in this case, there's nothing different. Okay, the backside reading plus the previous reduced level plus this reduced level here will give you the new height of the instrument. So change of point is, remember, the change of this instrument led to this backside reading and it led to another new height of instrument. So change of point is that point where it leads to determining another height of instrument. Okay, that is what change of point is, right? So you need to note that. Now we move to point 4. You are not working with this height again. You're done with this height of instrument. Now this is your new height of instrument. That's what you're going to use throughout. Okay, throughout the session. Okay, because you can see there's no height difference here. There's no height difference. It's just the height throughout the session. Once you understand it diagrammatically, you will understand this leveling of a thing. Okay, now look at it. To get this 0.4 now, this is just 1 meter. I will subtract 1 meter from where? From 204. You'll be getting this 0.4 to be what? Let me just be writing it because I want to make the video to be short, kind of a moderate time, you understand? So this height now, from this 0.4 down, would be 204 minus 1. That's about 203 meters. Okay, this from this 0.4 down to the sea level. Okay, now likewise, to get this 0.5, I'll be subtracting this guy from this height. That will now be about 204 minus 4. That's about 200 meters. Okay, now this final part here, which is my 4 sides. Okay, remember the height still remains 204 meters because it is the same height. If you check, it is the same height. I did not change that instrument. In as much as it did not change instrument, there will be no change of height. You get, the instrument was still there, viewing through all these points here. So it means it's the same height. Okay, so 204 minus 3.5 would just be about 200.5. Let's just call it 200.5 meters. Okay, so we can have it here. You can see, you see how these guys are. So I just indirectly taught you how to find the reduced level of point 1, point 2, any point on the Earth's surface using the height of instrument method. Now, in our next class, we are going to treat something different but similar. Okay, we are still going to make use of this diagram if we really need it. All right, so I don't know what else I'm forgetting to add, but then I think I am just through with this guy here. Okay, however, if I forget anything to add, I will add it in the next video. Okay, now we just treated 4 sides. Intermediate site. Okay, intermediate site, actually, you may really want to know what intermediate site is because you already know. Look at this guy. This is IS, right? This is B. This is BS. back side, and this is intermediate side. This is foresight, right? So intermediate sides are the readings, or is the reading in between back side and foresight. Okay, so you need to know that too. Intermediate side is the reading, or are the readings. The reason why I said is that there might be sometimes two intermediate or more intermediate sides in between the back side here and the foresight here. You can check that and you can verify that. All right, so that's just the reading here. So we have covered intermediate sides. Remind me, intermediate sides. This is foresight. This is intermediate side. We have covered change point. We have also covered reduced level. All right. So our next topic will be, our next lesson description will be calculating reduced level of points using given staff reading. We have just done this. We have just done this thing. We have just done it. Okay. So there's no point doing this one again, unless we are going to be given questions to calculate. We are going to use height of instruments to do that. So we are going to do this with another question. Okay. So we are going to also complete and construct. We are going to do that. We are also going to do this too. Okay. So I think at this juncture, I am through with you for this particular subtopic. Okay. So I'd like you to all go back and study with this lesson. Okay, study other aspect of it. All right. My name is Isong, and I remain your favorite tutor. Okay. Have a nice day. Thank you for your time and thank you for watching. Please don't forget to like, comment, as well as share. All right. That is if you want to motivate me to drop other feature videos. Okay. Thank you very much. I really appreciate your time.